Why, hello. How are you on this really fantastically wonderful day? I hope you're having a good day. If you're not having a good day, I hope it gets better. So let's talk. We talked in the last video about comparing fractions. We're moving on to adding and subtracting fractions. So before we move forward, let's move backwards a little bit and remind ourselves of a few things. The first thing we're going to remind ourselves is that the number one, the whole number one, can be represented in fraction form. And it can take lots and lots of different forms, okay? As long as the top number and the bottom number are the same, they all represent 1. That's because no matter how many pieces the shape is divided into, this just means that the whole thing is used up. The whole thing is shaded, what have you, okay? The entire thing. So again, the number 1 can take lots of different forms, and when you're deciding what it should look like, the bottom number of the other fraction will tell you what that number should be, okay? The bottom number tells you what to do. I've said that many times. There's also something called a greater than 1 fraction, a GTO. And this is what this looks like, okay? So this is divided into fifths. We know this because the circus tent of number 1 goes over this far, but there's a couple of extra bits. They're all fifths, but there are 7 of them, not 5 fifths, which would be 1, right? So this is a GTO, and all GTOs greater than 1 fractions can be represented as a mixed number. And we will talk about, and we have talked about, how one can change into the other and how we can easily do that, how we can turn this into this and this into this. So addition and subtraction of fractions. Guess what I'm not going to do? I'm not going to waste your time by talking about something like this. If the denominators are the same, it's very, very easy. You just add the top numbers or subtract the top numbers, and the bottom numbers, the denominators, stay the same. Got it? Good. Let's move on with it. Like really, I don't need to. What more do you want from that? It's about as simple and basic as it can possibly get. So let's talk about something like this. Okay, and this is where I want you to start writing this down. Starting here is what you're going to be writing down. So if there are 3 or of them, it works the same way. It's still really not that difficult. However, now you may or may not, depending on the situation, have a scenario, if you will, that the top number ends up being larger or equal or something to the bottom. Right? Now we know the denominator stays the same, so we just do that, right? 3 plus 2, and you can add these in any order you want. 3 plus 2 is 5, plus 1 is 6. Well, now we have a GTO, right? And that's, as a final answer, we can't really have that. We can't really have that as a final answer. So what we're going to do instead is we're going to turn it into a mixed number, okay? We can do that by decomposing, which we've done many, many times. Now again, should this fraction that equals 1, should it be 6/6 or 5/5? Right. The bottom number tells us that it should be 5/5. This equals 1. Okay, that equals 1. Right? And then how do you figure out, well, how many are left over? Well, we had 6/5. We took away 5/5, and we are left with 1/5. So the final answer in the most acceptable form possible would be 1 and 1/5. That's a little far apart from each other. I kind of like them to be a little closer personally. See what I mean? So you really get the idea this is a mixed number, 1 and 1/5. And that's pretty much that. Now, we're going to kick it up a notch for the next example, and then I'm going to have you try a few that are like this. Now this, Mr. Brown, this doesn't look radically different than what we just did. Right? And remember, pause the video as many times as you wish so that you write this down as neatly and carefully as you can. Doesn't look that much different. Well, let's find out to see if it is. The bottom number stays the same. So far, so good. And again, you can add these in any order you wish. 4 plus 5 is 9. 9 plus 11 is 20. Well, I think this is going to be a little bit different. Let's take a whole number fraction out of this GTO, and it's going to be 10/10 because the bottom number tells us what to do. And then let's find out what the leftover bits are. 20 minus 10. This is interesting. We were able to take 2 10/10 out of it. This equals 1. This equals 1, which means that the final answer in acceptable form, believe it or not, is 2. Now, what if it was, let's imagine that this was instead, it was 20, instead of 22, it was 28. Let's just imagine that. Go ahead, write it in there. Then we would pull out a 10/10, another 10/10, which would be 20. And are you serious, Mr. Brown? And then another 10/10, which would be 8/10. So yes, it is possible to decompose into a few. Okay, and yes, I actually want you to write this down, because now we've got a 1, and the leftover bits are 8/10. So the final answer will be 2 and 8/10. Now I want you to pause your computer for this next part, because I've got 3 examples that I want you to try on your own. I want you to pause this. Now, you might want to leave some space in between. Like I actually put these one on top, but you might want to spread these out a little bit. Okay? So pause it, write all 3 of these down, and you do this right now. Ready? Go ahead. Welcome back. Okay? I trust that you have done that. Okay? Now let's talk about subtraction. Okay? If we have a situation like what we used to do back in the olden days, was we used to just have a mixed number and we would take one traditional regular fraction out of it. Well, now we have 2. It's not really as bad as it looks, my friends. It's really not as bad as it looks, because instead of taking 2 little teeny weeny ones, what we're going to do is we'll just combine these 2 together, make the little caret right here. And instead of 1 7/8 minus 3/8, we'll just combine these 2. We'll combine this one and this one into a 4/8. And we'll subtract that instead. Does that make sense? Now, as far as the 1 7/8, we need to turn this into completely just a fraction. Just a greater than 1 fraction. And how are we going to do that? Well, what is the 1 going to turn into? 8s, 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 8s. Yeah. Yeah. What's the leftover bits? Well, actually, I apologize. I shouldn't have worded it like that. It's not really a left. It's like the other fraction doesn't really change. I shouldn't have called it leftover bits. So the 1 turns into an 8/8. The 7/8 just stays the same. And now, when we subtract those, I know it's not on the same line, I'm sorry, is 15/8, which is a GTO, right? Now, here comes the weird part. 15 minus 4 is 11/8. This is still not really a great answer, because 11/8 is still a GTO, okay? So really, in all honesty, you would actually want to change this again, like we did before. 8/8, right? And 8/8, and what's the leftover bit? 9, 10, 11, 3/8. So really, the more acceptable answer of this would be 1 3/8. Okay, but what's most important to realize is that these 2 combine together, and then these 2 turn from a mixed number to a greater than 1, so you can actually subtract. I'm hoping that for the examples that I give you, that the answer won't be as messy as this. That it won't be as messy. And here's one that you can do. Here's 2 that you can do right here. These 2. Okay? For this one, you're going to change the 1 minus minus. For this one, again, I don't think this answer is going to be as messy as this one. So pause the video. I want you to copy down this one. Again, leave some space in between this one and this one. I want you to try these on your own. Okay, take your time, write it as neatly as possible, and then we'll talk about it. Okay, have an absolutely fantastic day. All right, bye-bye.